This oral lecture is going to be on chapter 13, which is correlation, and it's going to be fairly short. Correlations are pretty straightforward. For the most part, they're easy to interpret. You need to think through the things that you're interpreting, but it's not difficult to interpret. So if you have questions, let me know. I follow the book. There's really not much supplemental material that I provide in statistics. I feel like, what the book is going through and between the calculations and trying to understand what statistical tests should be used for what, and then trying to do, the SPSS stuff, that you definitely have your hands full. So if you felt like you understood the material from the book, great. This will just reinforce it. If you didn't understand the material from the book, hopefully this will help out at least a little bit. And if you still have questions or if you are confused or something, then let me know and we can set up some one-on-one time, either via Zoom, the phone, or in or out of the office. Okay, so a correlation is another bivariate statistical test, and you use correlations when both variables are continuous. So when I say both variables, I'm talking about the independent and dependent variables. And remember, bivariate means you're testing the relationship between two variables. So when both of those variables are continuous or interval ratio, then you would use a correlation. The range of a correlation is from -1 to +1. When you interpret a correlation, you're looking for two things: the strength of the relationship and the direction of the relationship. So let's cover direction first. It's very straightforward. The correlation is either going to be positive, negative, or it's going to be 0. If a correlation is 0, that means there is no correlation between the variables. That means they're not related at all. It is almost, I can't think of a time I've ever seen a correlation of actually 0. And I also cannot think of a time where there has been, at least in research, I mean, hypothetically, people come up with examples, but in research, you almost never see a correlation of 0, nor would you ever see a correlation of negative or +1, which would indicate a perfect relationship between variables. In research, you're going to see values, correlation values between negative and +1. So the direction is either going to be positive or negative, although theoretically it also could be 0. A positive correlation means that as one variable goes up or down, so does the other variable. So if as one variable goes up, the other variable goes up. It also means as one variable goes down, the other variable goes down. So as long as the variables are moving in the same direction, whether it's up or down, and obviously it would be converse, so if two things went up together, they also would go down together, then it is a positive relationship. So just if you see an example or an exam question or something like that saying, as education goes down, as formal education goes down, assuming you're measuring education in years, income goes down. That is a positive correlation, because that also means as years of formal education go up, income also goes up. Another example would be contact with delinquent peers and delinquency. As contact with delinquent peers goes up, delinquency goes up, at least hypothetically. As contact with delinquent peers goes down, delinquency also goes down. So they're co-varying in the same direction, which means that that is a positive correlation. A negative correlation means that as one variable goes up, the other variable goes down, or vice versa. As one variable goes down, the other variable goes up. So an example might be education and support for capital punishment, and just pretend like support for capital punishment is a continuous variable. As education goes up, support for capital punishment tends to go down. As education level goes down, support for capital punishment tends to go up. As social support or family ties go up, crime and delinquency tend to go down. As social support or family ties diminish, crime and delinquency tend to go up. So make sure that you're able to give examples of both positive and negative correlations. So you should be able to tell whether a relationship or a correlation is positive or negative, but you don't know whether or not that relationship is strong or weak. So the strength, so I talked before about how the range is -1 to +1, with 0 being in the middle. The actual number, so a correlation might be like -0.40. The sign tells you the direction, the negative. That 0.4, or whatever that, what we call the R value, whatever that number is, tells you what the strength is. The closer to either negative or positive 1 that number is, the stronger the relationship. The closer to 0, the weaker the relationship. So if you almost envision a number line with -1, 0 in the middle, and +1, the closer the numbers are to positive or -1, the stronger the correlation. The more you start moving in toward the center, which is 0, then the weaker the relationship is. I mentioned before that 0 means no relationship, and a value of positive or -1 indicates a perfect relationship. Although you almost never see that actually play out in research, make sure that you understand theoretically what that means. So examples would be something like if you had a correlation of negative 0.87, that is a strong negative correlation. If you had a correlation of positive 0.76, that is a strong positive correlation. If you have a correlation of negative 0.05, that is a negative weak relationship. If you had a correlation of positive 0.14, that's a positive but weak relationship. If you have a correlation of negative 0.48, that would be a negative moderate relationship. And if you had a value of positive 0.36, that would be a positive moderate relationship. And your book talks about the threshold for what constitutes a strong versus a moderate versus a weak correlation and where those cutoffs are. And it's good to have the guidelines so you understand and can talk about, well, especially, when you're interpreting your own data, then you can say, this is a moderate correlation. And so it's important to have the guidelines, but just know that you might see different researchers, especially in that moderate range, they might vary a little bit. So like where your book, I think the threshold is like 0.50 or something, you might see a researcher call a correlation of 0.58 a moderate correlation, or they might say it's a moderate to strong correlation. So just so you know, that interpretation and those thresholds are not rigid. They're pretty fluid. But when you get like above 0.70, and if you're at like, 0.2, people tend to agree that those are strong and weak, respectively. 0.7, 0.8, 0.9, those are strong correlations. And when you get into, the 0.2s and 0.1s and 0.005, that's pretty universally agreed upon that those numbers are weak correlations. I mentioned before that the number, that negative to positive 1, is the R coefficient. So you'll see people will talk about Pearson's R. They're just talking about the correlation coefficient. The interpretation for a correlation, make sure you know that. A 1 unit increase or decrease, depending on the sign, in the independent variable is associated with a whatever increase or decrease in the dependent variable. Make sure that you can follow the formula in the book. Again, the book goes through that same 5 steps with, stating the null and the research hypothesis and going through the formula, figuring out whether the obtained value meets the threshold and then, talking about whether or not to reject or fail to reject the null hypothesis. Make sure that you're able to apply those same steps that you've been working with for several weeks now to the correlation. Also, make sure you at least can follow the formula and understand it for how to calculate a correlation coefficient. I'm not asking you to do that on the assessment this week. I may or may not ask you to do it on the final exam. If you're going to be asked to do it, it will be on the study guide, but you will never have to memorize those formulas. So just if it's on the final exam study guide, just make sure that you are familiar with it or you have a formula pretty accessible so that you're not digging around and needing to take a ton of time to do the calculation. But like I said, I haven't decided which calculations I'm going to use on the final yet. Just make sure at this point that you can follow it and that you understand it and that you know where to access it if you need to. You should definitely be able to interpret correlations. So if I give you a correlation of negative 0.84, you would need to tell me what that means. As this variable goes up, the dependent variable goes down. This is a very strong correlation is what you would need to tell me. If I said positive 0.80, it would be as one variable goes up, the other one goes up. if it was negative, then as one variable goes up, the other variable goes down. I can't remember which sign I said. So just make sure that you know how to interpret both the strength and the direction of a correlation using the two variables that are given to you. If a correlation is statistically significant, then you would reject the null hypothesis and say that the alternative hypothesis or the research hypothesis is supported. If a correlation is not statistically significant, then you would fail to reject the null and say that the research hypothesis is not supported. I thought there was one more thing I wanted to mention. Make sure you understand the line of best fit and how basically if you're plotting data points, so the independent variable and dependent variable would be on a grid. And if you were plotting different data points, the data points might be very close together or they might be very spread out. And then statistically what happens with the correlation is that line of best fit essentially kind of splits the data points. If the data points are close to that line of best fit, that means the correlation is pretty strong. If the data points are more spread out, that means there's a lot more error and that the correlation is much weaker. Strong and weak do not equate to statistical significance, so you cannot assume that a moderately strong correlation or that a strong correlation is statistically significant, nor can you assume that a weak correlation is not statistically significant. You will see weak statistically significant correlations. If there's a strong correlation, it is usually statistically significant. And when correlations are not significant, they do tend to be weak. But there are plenty of times where you will see a weak but statistically significant correlation. Remember that a bivariate association is a requirement of causation. So these two variables, like if you had two interval ratio level variables, you would have to run a correlation between them before you did anything with regression, because you need to make sure that they are associated at the bivariate level. But just because two variables are associated at the bivariate level, that does not mean that one causes the other. It means that there is an association. So if you think about that, there is probably going to be a very strong association between ice cream sales and the number of drowning deaths. So you might have a correlation of like 0.88, which is a very strong correlation, and it could be statistically significant. But would you say that ice cream causes drowning deaths or to go up? Or would you say that, because the correlation would be positive, or would you say that drowning deaths cause ice cream sales to go up? Causally, that doesn't make sense. So just think about it. What would cause both of those things to go up? Probably the heat, summer, temperature, something like that. But the thing is, when you're looking at bivariate, that's only two variables. So you have not controlled for something like the temperature or the season. So you can have variables that are very strongly correlated and statistically significant, but that does not necessarily mean that the independent variable causes the dependent variable. It simply means that you would take that next step. Okay, a correlation exists. Now let's add in some control variables and run a regression and see if that relationship still remains. And in the example I just gave, I'm pretty sure once you controlled for temperature, the relationship between drowning deaths and ice cream sales would completely disappear, meaning they are explained by a common cause, that being temperature. So keep in mind that although bivariate associations, significant ones, are required, they are one of three requirements for causation. That does not necessarily mean that they are causally related. So a correlation does not mean that the independent variable causes the dependent variable. It may or may not. At the correlation level, you don't have enough information to tell. All the information that gives you is whether there is an association, not a causal relationship. So make sure that you understand that those are two distinct things. So that is all I have for this chapter. Like I said, it's pretty straightforward, I think. If you have questions, let me know. And otherwise, I think you'll do fine on the assessment. You're not required to do any calculations. There's one true/false question, and the rest are multiple choice. But do make sure that you understand the fundamentals of correlations, independent versus dependent variables, the level of measure, all of the basic conceptual stuff. Make sure you understand that before you take the assessment.